Okay, welcome to the Energy Conversions Notes Review. I'm going to briefly highlight the notes for the energy conversions, which is the second part of the energy unit. We talked about the various types of energy the last time, and just going to talk about how these things convert or change from one type to another. So that's exactly what a conversion is. It's a change of one type of energy to another. Um, Kinetic potential, easiest to see on an everyday basis. I just kind of made that as a little side point because it's just something you see in your everyday life. The person here is jumping on the trampoline, and as they come down here and spring into the trampoline itself, the springs around the side will elastically bend and give the person elastic potential energy, and then it will convert that to a kinetic and bounce the person up into the air. Um, so you can just quickly see that kinetic to potential converts. And as they continue to jump on it, it'll continue to convert. Kinetic potential, kinetic potential. It's all kinds of fun. The skateboard is the same way. He has potential energy up here, and as he starts to head down, it's going to convert to kinetic, which means he's going to go fast. If he were up here starting, he's going to go faster. Why is that? Because he has more energy. These are things you know. If you looked at a ramp that was down here and then a ramp up here, you would say, this one up here is going to go faster. Well, it's going to go faster because it has more potential energy. Why? Because it's further from the ground. The further from the ground you are, the more potential energy you'll have. Review the various types of energy notes, the previous set of notes about GPE, if you've forgotten that. Let's move along. The pendulum is the great example of kinetic potential conversion. You'll probably see this on a test at some point, maybe even tested by me. But you'll probably definitely see it on a standardized test of some kind. It just shows energy conversion in its simplest form. You have mostly PE here because it's far off the ground, and as it kind of comes up here and stops, it's going to have mostly PE, and then it's going to start to go the other way, and then you'll have kinetic energy increasing. Why is kinetic energy increasing? Because the motion is moving, and as it goes down, as it gets pulled down by the pull of gravity, it's going to go faster, and therefore it will have more kinetic energy. The PE is decreasing because the KE is increasing. If one goes up, the other goes down, that kind of deal. So here you see this would be the point where the kinetic is the strongest or the highest. It's moving the fastest. And then it's going to start coming up here again. And the KE will start decreasing. And the KE starts decreasing because it's fighting. Whoa. Because it's fighting gravity at this point. And as it's fighting gravity, it's gaining PE. And then again over here, you're going to have PE. And this is going to be really high. And then it's going to start all over again. All kinds of fun. This is kind of my joke on chemical energy conversions. The SS Fat guy has lots of stored chemical energy in the form of excess fat, hence the SS Fat guy. This is chemical potential energy. It is sitting there waiting to be used. It looks like a lot of it sitting there waiting to be used. Well, he's like, oh, I'm going to ride around my boat a little bit, and then I'm going to go play some soccer. So he's converting a lot of that potential into kinetic. He's moving around, he's sweating, he's kicking the ball, he's having all kinds of fun, he's getting red cards. Well, then he's played for a long time, he's really tired, so he's going to go take a nap. He needs to refuel, he needs to get some more food. Chemical energy conversion, another great example, is photosynthesis. Photosynthesis, the process by which plants convert light plus some chemicals into some different chemicals, very vital chemicals to the planet's survival. Take CO2 from the air plus some H2O or water, add a little mix of sunshine in, and the chlorophyll in the plant's leaves are able to convert these two things into different organic compounds, mainly glucose. C6H12O6 is glucose, and 6O2 is a byproduct. Doesn't really use this, so it releases it, which is good for us because mammals require it. Another energy conversion you could even go a little further with. The sun produces nuclear energy in its core that produces thermal and light energy, and then down here combines with chemicals in the ground to create sugar, that wonderful food substance we love. Electrical energy conversions in your house. Um, Easiest things to see as far as understanding what energy conversion is all about. You plug something in the wall and magically it works, right? The radio plays music, so it converts electrical to sound energy. But if you actually have the radio on, not a CD or your iPod, there's an antenna here. And the antenna is receiving radio light, which is a light wave, into the antenna, and the antenna comes down and it transmits that light energy into sound energy, and boom, you hear it. It's amazing. The fan and the refrigerator both show electrical to thermal conversions. This is thermally making it stay cold because ejecting the hot air from it. And then this is thermally keeping you cool as it circulates the air. So this is just a couple examples. My hair dryer on the next one here. The hair dryer is a wonder of modern civilization. I'm sure you agree. Whether you use it or not, it's still a pretty cool device. Takes electricity that comes in. Doesn't come in from a magical place. Comes in from like a power plant, either from burning coal, which if you're burning coal to convert electricity, then to create electricity, then you're breaking the chemical bonds of the coal to catch it on fire and convert it. Or if you're using hydroelectric dam, then you're using the kinetic and potential energy of the water behind the dam to generate, push some turbines and create electricity. If you remember back to the various types of energy notes, I talked about that. The electricity's coming in. I don't want that to happen. And then it's kinetically making this fan move. Just moving around and around and around, and as it moves around and around and around, it's taking air in back here and it's blowing it over these things right here. Well, these things are thermally hot. I don't want this word thermally. We'll use it for now. These are wires that, when they're heated up, get hot. It's like a space heater, like a little heater you plug in and stand in front of. It's the exact same thing. So the air comes in, and as the air rushes over these warm things right here, it warms the air up itself, and then it blows it out here, and it makes your hair look beautiful. As a byproduct, though, it makes sound energy. I'm sure you're quite aware the thing's quite loud. But anyway, it's just a great example of energy conversion because you see so many different types within one device. A couple other ones down here. I suggest you pause the video and check it out. Of course, this is also in your textbook. Machines or energy converters, what they do. They convert energy from one place to go to another place. The bicycle here, the guy he probably ate a big breakfast, and now he has lots of chemical potential energy, and he's kinetically moving his feet or in a circle around the pedals, and it's turning this chain wheel or whatever, I don't know what this is called, but as he's turning that, then it's kinetically connected to a chain that turns the gear back here, and then this is kinetically connected to this is connected to the wheel that kinetically turns the wheel, and boom, the man goes off. Like that. I use the word boom. I don't really know if that's a word. Let's just pretend that it is. This is another machine. You don't think about these fingernail clippers being a machine, but they are. It's a elastically potential, I guess I'd say elastically potential, I don't know, device, the machine. It's kind of spring, and as you press down on it, it's going to compress the spring and clamp this thing to cut, hopefully, your toenail or fingernail. It's all about this, the law of conservation of energy. Energy conversions basically support this idea that you don't really create energy or destroy it, you just convert it from one type to another. Sound energy is, absorbed into walls and then it's, released somewhere. Mainly as kinetic energy into particles. But it's one of these things where everything is converted into another type of energy. Most of it is converted to thermal or kinetic energy eventually. But that's okay because it will eventually be converted into something else again. And that's kind of the beauty of energy. It's the ultimate recycler. You always recycle the energy. Here you have the mechanical energy conversion. That's kind of a good additional thing here. The guy has gained all this energy by doing work to get up here. If you remember from the various types of energy notes, the work is ability, or the work is moving a force through a distance. So somebody hauled this guy up here, and it required energy for him to get all the way to the very top. Well, when he got to the very top, he has a lot of potential energy. Well, as he starts going down, it's going to start converting to KE. He's going to have not as much KE here because he's not going that fast. Remember, KE has everything to do with speed. Here he's going to have more KE, more KE, more KE. Wow, it's a lot of KE down here. Very little PE though. Why? Because if you have high PE, you can't have high KE. It's impossible to have both of these. They always balance each other out. So if you have high PE, you have high or low KE. If you have high KE, you have low PE. Go look at that energy skate park simulation that I put on the website. Open up that simulation and pop the bar graph on and kind of watch the bar graphs on that thing just kind of bounce up and down, up and down. It's very cool. Shows that conversion. I'm going to just pause it here for a minute. Actually, I won't pause it. You need to pause the video and kind of take a look at this review sheet. We spoke about the sheet in class. See if you can answer these problems down here. I'll give you a hint. All of the mechanicals will always equal 50. So in this case, 0 plus 50 is 50. All of these are 50. These are easy. Kinetic, potential, potential, kinetic, potential, potential, kinetic, kinetic. Oh no, I'm sorry. This is potential because it's at the highest point, the exact moment where it stops, like right here. Another review sheet. Again, pause the video, take a look at this thing because it does have some good information. You don't need some of this. You don't need to convert. You don't need to calculate this. These you should know. This is the joule. Ooh, that was bad. Should probably undo that. This is another kinetic or pendulum problem. A couple more. Pick out if they're kinetic or potential. Again, pause it if you need to. And this is the one I want you to focus on. This little guy here jumping in the little bucket of water. Great example. Here he has PE 15,000 joules. Down here he has 0 PE. Well, how much kinetic must he have? He must have 15,000. Why? Because it must be the same. If he had 15,000 PE up here and now he has 0 PE, that means that it must all be kinetic, so he's moving faster. What you should notice is as he's going down, his KE is increasing. Here it's 0. Here it's going to be 3,750. How do you know that? I know that because 3,750 plus 11,250 equal 15,000. Remember, ME is equal to KE plus PE. 7,500? What does this must be? It must be 7,500. This must be 11,250. He's moving faster here. He's closer to the ground, so he doesn't have as much PE. He's moving faster, so he has more KE. So the faster he moves, more KE. Closer to the ground he is, less PE. Pause it, take a look. There's another good one right here. This little ramp one. Yikes. That's horrible. I'm going to take that back. Anyway, hope it helps. Just review it, pause these worksheets, and see if you can answer them. And I guess I'll see you in class.